In greetings and welcome. So here we are going over the homework from last night, talking about common logarithms, or natural logarithms actually more specifically. So we were doing our first glance at those. So looking at the work, we are on page 736 if anyone's interested in that, in our advanced math text. Which problems would you like me to go over? Let's see if I can open that up here. So, what problems, what preferences would you have? Preferably earlier ones. 41. Were there any questions prior to 41? Yeah?
They would seem pretty self-explanatory.
I'm on the right page, right? Yeah. Okay. 41. Yeah, because we didn't do any inequalities, did we? Directly. I think we'll be able to treat this. Oh, nope. We're saving Excel for later. There we go. Paste.
Treat it like a normal, like it's
Yeah.
equal if you're solving.
Yeah, I think we can, unless we multiply or divide by a negative is the only thing we'd have to worry about. So for this problem, I would likely just ln both sides. So ln of 60.3 is less than ln of e to the 0.1t. And then I could use our power property to pull this out front. So ln of 60.3 is less than 0.1t times ln of e. What is ln of e?
1.
1, right? Because e to the what power is e? 1, the first power, right? And then how would I get t by itself here? Divide by 0.1. Do I have to flip the inequality when I divide by 0.1?
No.
No, we won't have to. So
It's only that case if you divide or multiply by a negative.
correct. So only if we multiply or divide by a negative would I have to. So I get t. This is less than t, or I could flip the whole thing and get t is greater than ln of 60.3 over 0.1. So let's actually evaluate what that is. So ln. I like how I don't have to switch between degree or radian mode for logarithms. I keep thinking, like, do I have to? It's like, no, these are just numbers. It just works out. Divided by 0.1, and I get t is greater than 40.9933. Is that the right answer, I hope?
Yes.
Nice. Yay for us. Yeah, it's somewhere. It's in the margin somewhere. Yeah, so they actually left the t on the right-hand side of the inequality. I'm a fan of writing variables on the left, so that's why I'd flip mine around, but it doesn't matter. So, otros preguntas. What other questions do we have?
43.
43. Okay, yeah, that one's a little bit sneakier. Actually, that one's fancy. So let's paste this. Scale it up a little bit. Upscale. So let's see. What are your guys' thoughts on this one? What would your instinct tell you?
Divide both sides by 22.
By 22?
I would have done 40.
I'm not guaranteeing to say that you'd be wrong, Zeb. I'm trying to think of. I don't know where you. Yeah, that's 22 there. I'm not sure what route you were taking. It's possible you did find another one. But my thought is I'm going to try to get the e by itself so that I can log both sides. It's kind of my general strategy that I'm considering. So I'm going to just slowly move everything away from the e to the x, or e to the 2x thing. Half minus 1 is going to be negative a half. I'm not going to do any fraction work for that. Equals negative e to the 2x. And then I would change the signs, dividing both sides by negative 1, or whatever you want to think of that as. A half is equal to e to the 2x. And now that I get e by itself, or as much as I can, this is when I would ln both sides. So ln of a half is equal to ln of e to the 2x. I can use my power property. That's the great thing about logarithms is that they can take a variable out of an exponent. All right, they're one of the, I think they're the only thing that can do that. ln e once again is going to be 1, and then to get x by itself, I'd divide by 2. Let's see, so I'll get x is equal to ln of 1/2 divided by 2. Now, technically, even if you didn't have a calculator last night, you could figure out what ln of 1/2 is. Does anyone know how? If I think of that as ln of 0.5, or that's ln of 5 times 10 to the negative 1, right? So that's going to be ln of 5 plus ln, or actually log. Oh, well, wait. No, we do also, No, this is only helpful if we were working in base 10. If these were logs, we could use the charts to kind of figure out 0.5. But yeah, never mind. Never mind. Scratch that idea.
Doesn't the chart have ln?
It does, but not a 0.5. I was thinking I could use the shift decimal trick because it wouldn't have had ln of 10 to the negative 1, which is another decimal. So yeah, that one wouldn't have worked out as easily. So ln of a half. So thinking of 2.7128, right? 2.718281828. Sorry. So what power is a half? It's got to be something negative, likely, right? So ln of 0.5 is negative 0.6931. Divide that by 2. And I get negative 0.347. That's what I end up getting. And hopefully, it's blurry there, but believe me, it's right. So there's 43. So their answer was a little bit different than mine, right? 3466. Mine was 3.
You just rounded.
Okay. All right, yeah, why did I round? Huh, I wonder. I think I saw the 0. I assumed I was at 4 decimals. I'll keep going. Let's see, checking against the calculator. That would have been, 66. What do you know? Even better. 4 decimals. Sounds good to me. All right, did we have any other cool ones?
58.
58.
I was wondering if there was like an easy way to figure out A, because I knew it was a little over 11 years.
Yeah, there will be.
I didn't know how to figure that out without sitting here doing it like adding 6.3%, like getting the 6.3% and adding it.
So let's see. Let me give this problem a read. So it says, Jenny Euler deposited money in an investment account that earned 6.3% interest. So let's see. So that's my rate. So R is 6.3%, which is equal to 0.063, right? If I want to have a decimal representation of that. Compounded continuously. All right, so that means the formula I'm using is A equals P e to the RT, apert, ape rate, apert, something like that. So that's the formula I'm using. So I know R, I just found R. E is the constant, right? So E is not a variable in this case. And then they ask us the question, how long will it take to double the money in the account? And you might be like, whoa, I don't know A, I don't know P, I don't know T.
See, that's what I...
Right? And that's the issue. But we can actually plug in some hypothetical values. Let's just say A is 2 and P is 1.
Now what I did was A equals 2P.
Oh, wow. So you actually, I like that. That's a clever approach. So it's saying that A is equal to 2P and just let P be itself.
Yep.
That works as well. Actually, I'm going to do it that way just to solve it generally. I'm kind of a fan of that. Well done, sir. I like it. So let's plug in what we know. So 2p is equal to p e to the 0.063t. Right? So, and then if I divide both sides by whatever p is, those will just cancel out. And yeah, that's what I was going to just plug in some general value that as long as a was twice as much as the initial amount, it wouldn't have mattered. So we'll get 2 equals e to the 0.063t. And now what do you think we should do? How can I ever get this variable out of an exponent? I can ln both sides. I don't know if that's what I heard. Technically, I could also log both sides, or log of any base for that matter, but... And then I could pull this down, and I'll have ln of 2 is equal to 0.063t times ln e, but you guys all know that ln of e is 1, so I'll do divide by 0.063, 0.063. I don't know where that 6 was going. So I'll get t equals whatever ln of 2 divided by that is. 0.063. And I'll get 11.0023 years for compounding continuously. So that's pretty cool. And the neat thing about this, if I wanted to make a double formula, if I wanted to come up with a formula just called double time, I can just do ln, I was just going to do my capital ln, ln of 2 divided by your rate, and it would just tell you how long it takes for anything to double once you know the rate. Right? So if I wanted, I could, so ln of 2 divided by 0.1 would be the amount of time it takes to double if you're compounding continuously and you're earning 10% interest. So in 6.93 years, you can double your investment.
Try ln of 2 divided by 0.063.
Right? Isn't that what I had? 11.002? Right. So I do have to make sure I close that parentheses, I believe. Yeah, so I mean, if I'm, or what if I was earning like 80% on my investment, something crazy, I could double in less than a year. Wow, that's weird. So there we go. Let's look at part B, is it? Part B, the rule of 72. I might pull up Excel for this. States that if you divide 72 by the interest rate of an account that compounds continuously, the result is the approximate number of years that it takes for the money to double. Do you think the rule of 72 is accurate? Explain your reasoning. I
said no, because 72 divided by 0.063 would be far greater than 11.0023.
Now I think it's Ben Franklin might have been the guy to figure out rule of 72. I don't remember. I thought. No, I guess I don't remember. I thought, who was the guy? Oh well. Well, apparently this Luca Pacioli guy had something to do with it. Good for him. Good for him. So let's see. So yeah, Zeb's got the right idea, is that, right, trying it out, coming up with a counterexample would make the most sense. So it says divide 72 by the interest rate. So yeah, so let's, in our example, what is 72 divided by 0.063? Or you know what they mean? I think they mean the non-decimal version of the interest rate.
Yeah,
like that. 72 divided by 6.3.
If it was the non-decimal version, then if the rate, I'll think about it, if the rate was 100%, then it would only take 1 year to double.
Right.
However, according to the rule of 72, it would take 72 hundredths of a year.
Yeah, so it's definitely going to be dividing by the percent version where you didn't switch the decimal place. So yeah, so Zeb's saying, I guess that's an example right there. If it's 100%, it'd take 0.72 years to double, but compounded continuously. What is ln of 2 divided by what do I need? Point. Well, actually, it would just be 1. Yeah. Right, so 0.69 years compared to 0.72. So it is off a little bit. Let me actually open up a quick little spreadsheet. File, new workbook. That's the one we'll be working with in a moment. Opening, 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 thinking, pinwheel. Oh, don't crash on me now. Okay, here we go. So let's do rate. Come on now. There we go. And then, seriously? All right, there we go. Years to double. And we'll do the, seriously? Are you lagging out this much? Shame on you, computer. You're embarrassing yourself. We'll do this one, ln of 2 divided by r, which is technically the exact value. Compare that to 72 divided by r. I guess I'll write times 100, indicating that the rate is in percent form, not in decimal form. So let's say our rate is 0.063, something like that. Actually, wait, I need one more thing, don't I? Oh, no. Yeah, maybe it makes more sense. Let me, since I don't have to have it specific to given time, the times are going to be different, I can just actually solve this for all sorts of rates, is the way that it might make more sense. So let's see. So I might, oh man, seriously, laptop, you're really embarrassing me. You are quite embarrassing. 0. Let me do let's start with like 1%. All right, can I close something here maybe? I do have a lot open. Let me see if I can save. Don't blame my laggy computer. It's trying really hard. Oh my goodness. Shame on you, computer. All right, closed one thing. Let's see if this helps. So let's see. Then I'll do. I'll have this increase by like 0.5%. So equals the previous one plus 0.005. Still lagging. All right. And then this one will just equal. Actually, is there an ln function? Good. Ln of that. Nope. Ln of 2 divided by that is what this cell will equal. Right? Wow. And that's what we got earlier. And this one will equal 72 divided by that times 100. And what did I do wrong? That's weird. It shouldn't be 0. Oh, maybe I have to divide it and then after that divide by it. It should have been the same difference.
You're dividing.
All right. Well, that's what it ends up. That's what we got earlier, right? Yeah. Well, all right. And now I'll copy that down, and then I'll just copy it down for a whole bunch. It's a shame. Poor Excel. It's trying hard. It's really my computer's fault, not Excel's. So let me just drag this down for a whole bunch of percents. And hopefully my computer doesn't die.
Wait, were you doing the wrong rate?
Yes, but I'm trying it for a whole bunch of rates. So we can see if the rate is 1%, it's off by like 2 years, 2.7 years. Here it's off by 1.8 years. Here it's off by like 1.5. Actually, I could even have it calculate the delta here equals that minus, actually I'll do it in the other order, C4 minus B4. Hopefully this isn't how slow Excel is going to be later today. We might end up doing a break before our thing. So that's how far off it is. And if I drag this down, it'll tell us how far off. So I went all the way up to like a 50% rate, which would be ridiculous in terms of investing. And then I could even do something like, what is the average? No. Of all of this data. And it will tell me how far off it is on average. Actually, at some point, I think it might even go negative at some point, but okay. So on average, it's off by like 0.22 years, which isn't that bad. You know, I mean, it's only off by like a quarter of a year, right? A tenth of a year, even less, right? Look, like for this one, it's off only 0.07 of a year. So, I mean, like, it's a pretty quick rule, I guess. If for some reason you didn't know ln of 2 and you were trying to make a quick decision on an investment, whether or not the rate was any good, you could just do like 72 divided by that rate and then at least have a general idea of, you know, how close is this. But, yeah, so it's kind of an interesting little relationship there. What actually is ln of 2? Right, so ln of 2 is 0.69. So I wonder, yeah, that's weird. We'll have to consider some of this stuff later. But yeah, so it does end up being an okay-ish, within a tolerable range, I guess, depending on what you tolerate for being off. But yeah, so it's kind of an interesting little rule they have. So I think that covers kind of everything from the homework. So are we good for the homework? I think so. We're good.